and welcome back to my online teaching platform. We are still on application of differentiation, but we are now focusing on the concept of tangent and that of a normal to a given curve. All right. So let's look at our sixth question. Find the value of c for which the line y is equal to 3x plus c is perpendicular to the tangent of the function y is equal to x squared minus 1. All right. So let us represent it with a diagram. The given statement, let us use a diagram to represent it. So let us get our curve. Suppose I have a curve in this form. Okay, I'll use a diagram to explain it. If I have a curve in this form and I have a tangent to the curve. So if this is my curve y is equal to x squared minus 1, and I have a tangent to the curve. So let me bring my tangent here. Suppose I have a tangent to the curve at, let me use a different color, at this particular point. So where I've used the red. So if the tangent to the curve is at point A, I put A over here. Okay. Now they are saying that this tangent has a line. Okay, there's another line here. This particular line. Okay, this is a straight line because it's a linear function. So this function is perpendicular to the tangent of the curve. Right. So let us draw or indicate such line. Okay, so a line is perpendicular to this. I'll now bring that line. Okay. Okay. So the line in color green becomes the normal. Okay, since it's perpendicular. So this is our line which is perpendicular to the tangent to the curve, right? So this is our line y is equal to 3x plus c. All right. And the reason why we have it as the normal is that they are saying that the line y is equal to 3x plus c is perpendicular to the tangent of the curve because y is equal to x squared minus 1 is a quadratic function. So that is the curve that we have here, right? That is the curve y is equal to x squared minus 1. And the tangent to the curve is the line here, this particular one. This is the tangent, right? And we have another line, which is y is equal to 3x plus c, which is also perpendicular to the tangent. So it means the line y is equal to 3x plus c becomes the normal since it's perpendicular to the tangent. Okay. Now we know that the product of the gradient of the tangent and the gradient of the normal is always equal to -1 since the two lines are perpendicular. So we can name the first gradient as m1 and so we have the gradient of the tangent to be m1, then the gradient of the normal to be m2. So we know that our m1 times our m2 must give us a result of -1. Okay. Now let us deduce the gradient from the straight line. So given a straight line, you can get your gradient from the line using the general equation of any linear function. So y is equal to ms plus c. Then you compare it with y is equal to 3x plus c, right? So looking at the two equations, you can see that the coefficient of x here is what we term as the gradient. That's the slope. So you are going to compare the two coefficients of the x. So it implies that m is equal to 3. So our gradient for the normal, the line which is perpendicular to the tangent of the curve, is 3. And we have labeled that gradient to be m2. So we will now say that the gradient of the normal, which is m2, is equal to 3, right? Okay, so that's what we have done now. Now we also learned that, now let us get the gradient of the tangent, okay? Now the gradient of the tangent, which is the m1, which is the m1, is equal to the gradient of the curve at the point where the line y equal to 3x plus c meet the tangent. So the gradient of the tangent is equal to the gradient of the curve, right? So let us get the gradient of the curve, which is dy dx is equal to, so we are going to differentiate our curve. So our curve is y is equal to x squared minus 1. So let us differentiate. We are going to get 2x as the result. So this is the gradient function of the curve. So this becomes the gradient function of the curve, right? Okay. Now, so this gradient function is the same as the gradient of the straight line. Okay. We are going to use to find the gradient of the straight line. Now, we want to know the value of x for which the product of the two gradients is equal to -1. The gradient of the tangent and the normal is equal to -1. So we are going to use this one as our m1. Okay, sorry, m2. Not sorry, it's m1 rather, not m2, because we are dealing with the normal, which is m2, and the tangent is the m1, and that of the tangent is the same as the curve at where they meet. So learn that m2 times m1 will give us a result of -1. So we have our m2 to be 3 and our m1 to be 2x, and all will be equal to -1. So we are going to get it to be 6x is equal to -1. So we continue to get, we divide through by the coefficient of x. That will give us -1 divided by 6. Then positive 6x also divided by 6. So here will be x is equal to -1 divided by 6. All right. So this is the value of x at the point where, when we multiply the two gradients, we get a value to be what? We get a value to be -1. All right. So after you have obtained this value of x, you will now use it to obtain its corresponding y value, right? So it means at this particular point, let's look at it. At point A, the y component is, the x component is -1 out of 6. So we are left with the y component. So let us now find the y component. So since the x is equal to -1 out of 6, to find the y component, you just plug the value of x into the curve to get its corresponding y value. All right, so that's what we are going to get now. So we have the function to be y is equal to x squared minus 1. So when x is equal to -1 out of 6, we get our y to be equal to -1 divided by 6 all squared minus 1. So we are going to get y to be equal to 1 divided by 36 minus 1. And this will give us a result of negative 35 over 36. All right. So this will give us a result of negative 35 over 36. Okay. Now this becomes the y value at the point where the curve touches the tangent or the straight line to form a tangent. And that's the same point the other line y is equal to 3x plus c meet the tangent to form the normal or the line which is perpendicular to the tangent. All right. So it implies that the y component of the point where the tangent touches the curve is negative 35 divided by 36. All right. Negative 35 divided by 36. So we have the point at that place to be point A. So it's going to be negative 1 divided by 6 against y value of negative 35 divided by 36. All right. Now we have to find the value of C in this particular line. All right. So since we have two coordinates, we have now obtained the two coordinates of the point where the line y is equal to 3x plus c meet the tangent of the curve. So we are now going to, since we have the point A to be the point of intersection, it means the coordinate of point A satisfy this equation as well. So wherever you see x, you put negative 35 divided by 36, then all equal to 3 also multiply the value of c. So the value of x, which is negative 1 out of 6, then plus c. So we are going to get negative 35 divided by 36 is equal to negative 3 divided by 6, all right, plus c. So we have to make c the subject. So we are going to get negative 35 plus 36. Then we transpose the negative, transpose this one to the right left hand side. It becomes plus 3 out of 6, all equal to c. Then we need to find the LCM. So we have 36 here. So here become negative 35. So here will be 18, all right, all equal to c. Okay, so when you add 18 to negative 35, you are going to get a result of, I think, 17. All right, 17, negative 17. You get negative 17 divided by 36 to be the value of c. All right, because negative 35 plus, okay, 6, okay, negative 35 plus this. All right, that's it. So you get negative 17 out of 36. So therefore, c is equal to negative 17 divided by 36. All right. Thank you for watching. Please do not forget to subscribe to my YouTube channel, which is Math with Ebefa. And you can equally share with others to also like and share. Bye for now.